My mathematical expertise is in topology, which means I study the various shapes that occur in mathematics. These can be familiar shapes like the sphere, the Mobius strip or the torus, but it also includes stranger shapes like the Klein bottom or the tesseract. The questions I study are rather abstract, but some of the methods I use can be applied to real-world questions. Let's look at one relating to doughnuts. There are many exciting varieties of doughnuts. Broadly speaking, they fit into two types, the American ring doughnut and the European jam-filled doughnut, sometimes known as a Berliner. Humans can tell them apart very easily, we just look for the central hole. But how can we get a computer to distinguish them? And how can we be certain the computer is correct? By which I mean mathematically certain. Let's take our starting point as having 3D scans of the doughnuts, from something like a CT scanner or a 3D ultrasound. The output of the scan is a list of points we can draw in 3D. Looking at the scan, we can clearly see the hole in the ring doughnut, and just about see that the European doughnut is hollow. I save this list of points to a computer and use it to build a simplicial complex. This is a combinatorial shape made from edges, triangles, and tetrahedrons. I do this in a way that depends on a parameter that is related to the length of the edges. We often refer to this parameter as time. Now I have to do some difficult mathematics. I calculate the Betti numbers of these simplicial complexes at varying times t. That is done by the means of complicated formulas, which have been turned into fast computer algorithms. I then combine the output as time varies to obtain a simple diagram called the persistence barcode. The key idea is that longer lines are more significant features. In both cases, we can see some noise coming from the sampling of the points. The long black line in both barcodes tells us that each doughnut is a single piece. For the European doughnut, the long blue line tells us there is a two-dimensional hole, the hollow where the jam goes. For the American doughnut, the long red line tells us we have a one-dimensional hole, the centre of the ring. Hence, we can be mathematically certain that the doughnuts corresponding to these scans are different. To summarise, persistence barcodes measure topological and geometric features of shapes that we can interpret using rigorous mathematics. This idea, which is part of topological data analysis, combines advanced mathematics and modern computing to solve real-world problems. This technique has been used in many different areas, including image and signal analysis, a range of medical applications, particularly cancer research, and modelling porosity and conductivity in physical chemistry. Thank you.